here at the Movement Innovation Lab at Queen's University Belfast, we are interested in how the brain controls movement. We're very specifically interested in how we pick up information through our eyes, through our ears, through our fingers, through our movements. How does the brain use all this information to decide when and how we act and control our movements that we perform in everyday life? So this research project, what we would really like to be able to do is to use current technology to develop new ways to help people with stroke, say, to move better. So what the plan is that we will take sensors, lots of low-cost sensors we have now, for example, the sensors we have on our telephone, on our wrists and watches, things like that can track movement. We'll use that technology and integrate it with visual displays that we have on a computer screen. So we'll use computers to generate virtual environments, and within those environments, the sensor technology will control the movement of something that happens. So for example, if I'm holding something in my hand here and I move it left and right, that will control the movement of something in like a video game. So because you can see your movement in the game, that will encourage you to move in a specific way. But what's interesting about what we can do is change how that movement is represented in the game. So we can make it appear that your movement is larger than it really is in real life. So it gives you additional feedback and gives you additional motivation to try and move that little bit better. What's interesting also about these game-type contexts or gamification of movement is that the feedback you get is the form of a score in the game. So say you played on Monday and you got 25, on Tuesday you might try to get 30. So you know as your score improves, your movement's also improving, and that becomes a great motivator for somebody to really try and move that little bit better. We've worked with older adults before in trying to improve balance, and also people with Parkinson's. So we're very excited about this project with NICHS to be able to look at stroke and to be able to see what can we do in that space. So what's interesting about this project is we're going to have to bring people together from lots of different scientific disciplines. So we'll be working with our engineering department here in Queen's, computer science, here in psychology where our expertise is about movement and motivation, but also with clinicians, physiotherapists, doctors as well who treat these patients, and of course patients themselves will be involved and their caregivers, because we want to make this a success for everybody. Having all those people's input helps us ensure that we will have hopefully some sort of intervention or technology that people could use in their own homes after the project is finished. So we'll be looking for people to get involved, and once we launch the project we'll be sending a call out to get different participants to come along here to the lab so we can have a chat, we can explore current systems to help us develop a better system. We hope to do that within the year, and then what we'd like to be able to do is trial that a little bit more with more end users and hopefully have something that people could use in their homes in the next couple of years.